Okay, so last week we started the capacitors and inductors. So we are continuing with that topic. Last time we discussed only like under the DC condition, or else when the capacitor is fully charged or fully discharged, what is happening. So we have done all these questions. Do you have any issues with those questions, guys? Are we all good? Okay, so if you don't have any issues, we are going to start this part like the first order circuits. There are again capacitors and inductors. We call them first order circuits because we can describe these circuits using a first order differential equations. That's why we call them, that's why it comes as the name is first order circuits. Again, if you have forgotten everything that we have learned so far, still now this is a different section, you can still learn just with the content that we are learning today. So please be please pay attention, and if you don't get it, or if you need further clarifications, you can ask questions, because again you get one question from this one normally in your final exam, and it is easy part where you can score full marks. Okay, so before we will start solving these questions, I will explain you the theory. So if as you haven't done your lecture, can you please note down these things, because we are going to use two equations mainly, four equations. So if with these four equations, we can solve any first order circuit. And you don't have to remember any of these equations. You only need to know how to apply these equations. Okay, so please note down the things that we are learning, because you haven't done your lecture yet. Okay, now let's see what do we mean by first order circuits. So first order circuits, as I told you at the beginning, we give this name because we are defining these circuits using a first order differential equation. So you have done differential equations in your maths, but you don't need that maths knowledge, because you are not going to solve a differential equation. You already have, you will get the equation, solve the equation. You only need to use the equation. So there are two kinds of first order circuits. First one is the RC circuit. And the second type is RL circuits. RC circuit means R is resistors, C means a capacitor. So in a circuit, if you have resistors with the one capacitor, just one number, one capacitor, we call them RC circuits. And in the RL circuits, you have resistors. It can be many resistors and just one inductor. So if you have resistors with one inductor, we call that a RL circuits. There are other circuits as well. We have RLC circuits. So you don't have any of these in your syllabus. If you do electrical engineering in future, you will learn those. But for your syllabus, we only have RC circuit and RL circuit. So in RC circuit, you have resistors and one capacitor, and in RL circuit, you have resistors and one inductor. Is that clear so far? Any question?
I think it's clear so far.
So let's take this one and let's see how it looks like. So let's take RC circuit. So I'm going to draw a circuit to show you how it looks like. So we have, there can be any in different ways. So we have a circuit like this. We call this a RC circuit. Why is that? We have a capacitor. We have resistors. It can be one or many resistors, but you only should have one capacitor. So this one, we call it a RC circuit. So when you have a RC circuit, what is happening is, can you remember guys, last week we discussed capacitor consists of two metal plates, and in between the plates you have an insulator. Am I right? So if we connect this capacitor, what will happen? When we just connect it, a current will flow from this voltage source, and the current comes to this node, it's splitting, and the current is going all the way up to here, and the current can't cross through the capacitor because there is an insulator in between the two plates. So what is happening? This will be charged. Am I right, guys? Is that what is happening? After some time, when the capacitor is fully charged, we don't see a current going into the capacitor. The whole current will go like this. Do you agree with me, guys? Can you remember we discussed this last week? The capacitor has a capacity. It can't, when the plates are saturated with electrons, it will be fully charged and the current won't go to the capacitor. The current will flow the other parts. Am I right? Is that what we have discussed?
Sorry, the current will actually stop in this whole part of the circuit?
Yes, it's not the current, the electrons are flowing, isn't it? And that's the conventional current, but electrons are flowing from one side. So electrons are flowing this direction. Electrons are flowing this direction, and electrons will store in one plate, and the other plate will be charged positively, isn't it? The current won't cross the two plates, but the electrons will accumulate on the plate and it will charge negatively, and the other plate will charge positively. So there is a electric field because of these different charges, and the energy will be stored in the capacitor in that way, isn't it? Is that what we discussed?
Yeah.
Yeah. So now after some time, the capacitor will be fully charged and there is no electrons go into the capacitor. All the electrons will flow in the opposite other direction. So the red arrows are for the conventional current. Conventional current is opposite to the electron flow. We have discussed this in the first week, if you can remember. So the green arrows are for the electrons. We normally show the current flow, not the electron flow. That's why I drew the red arrows, which is our current. So, so after some time, the capacitor will be fully charged and electrons, the current will flow in the red path. Am I right, guys? So you have learned last week how do we find the voltage across the capacitor? Can you remember? How do we find the voltage across the capacitor? If I ask you to find the voltage across the capacitor, if I just write it as V naught, how do we find the V naught, guys? When the capacitor is fully charged, there is no current going, so it will act as an open circuit. Can you remember that? So the circuit, when the capacitor is fully charged, your circuit will look like this. And if you find the voltage across these 2 points, that is your voltage across the capacitor. Do you agree with me?
Yeah, we're good so far.
So how do we find the V naught? From last week knowledge, you should be able to find the V naught. How do you find the V naught? So this resistor is not functioning because there is no current going across that. Am I right? V naught is the voltage across this 9 volts. Do you agree? This is your V naught, isn't it? Am I right, guys?
Right, because they're parallel anyway.
They are parallel, yes. So this is not functioning. So these 2 points and these 2 points are the same points anyway, isn't it? Because you don't have this one. You don't have a resistor over here. So that's the same 2 points, isn't it? So how do you find the V naught? You use the voltage division rule. This 20 is divided between 3 and 9. Am I right? So how do we write the voltage division rule for the 9, voltage across the 9? That will be total voltage. If you can remember, total voltage 20 times 9 over 9 plus 3. Am I right, guys? Is that how we write the voltage division rule? So this voltage V naught will be what? (20 times 9 divided by 12). So that will be 15 volts. Is that right? Am I right, guys? Is it clear so far? Any question?
I think it's good so far.
Okay, so when we can say when the capacitor is fully charged, we need this information. We need this information. So I'm writing it somewhere. So when the capacitor is fully charged, the voltage across the capacitor is equals to 15 volts. So we found this. Now let's see in this RC circuit, what we are looking at is when the capacitor is charging and discharging, how this voltage across the capacitor is changing. So in this circuit, I will redraw it because otherwise I'll try to clean this one a little bit. Okay, now what I'm going to do is, so in case if I open this one, for example, if I have a switch here, if I open the switch after some time, now what will happen? If I remove this part from the circuit, that means if I open the switch, my circuit now will be this, isn't it? Am I right, guys? If I open the switch, if I disconnect this part, the left-hand side of the circuit, I will only have the right-hand side of the circuit, and right-hand side will look like this. Do you agree?
Yep.
So here, now what is happening? When I just remove the left-hand side, now I have a fully charged capacitor. So what is happening? Now the capacitor is discharging. It will provide a current. So it is discharging the current, or else it is the electrons will flow in the opposite direction. But this current is not a constant, or else the voltage across the capacitor is now changing. Now it has a 15 volts at the beginning. Due to this 15 volts, it provides a current, and that current will flow till this voltage across the capacitor is becomes 0. When it is fully discharged, the voltage across the capacitor will be 0. Do you agree?
Because it's expelling all the electrons that it's accumulating.
Yes, yes. So it had electrons accumulated on the plate. So those electrons will be flow till this will be fully discharged. Because we have positively charged and negatively charged two plates. So now what you can say, guys, when the time is, for example, just I take, when the time is equals to 0, when the capacitor is fully charged, when the time is equals to 0, voltage across the capacitor was 15 volts. Am I right?
So before it's charged?
It was fully charged, yes. When it was fully charged, the voltage across the capacitor was 15. Now, when the time goes to infinity, that means when it is fully discharged, the voltage across the capacitor became 0 volts. Is that right? Look at this one. So when I just remove the left-hand side of the circuit, the voltage across the capacitor was 15 at the beginning. Now, when the time goes to infinity, after a long time, the capacitor will be fully discharged and the voltage across the capacitor will become 0. Do you agree with me?
Yep, that makes sense so far.
Now what you can say, how do you see this one? So if I draw the voltage across the capacitor, if I draw the voltage across the capacitor, this is the voltage across the capacitor with the time. At the beginning, I had a 15 volts, and when the time goes to infinity, the voltage is changing to 0. So this is how it behaves. This behavior we didn't discuss last week. This is what happening when the capacitor is discharging. So this is what we are going to learn today. We are going to find the equation. So this is not a straight line, this is a curve. So we are going to find this equation for this curve when the capacitor is charging and discharging. So this is just an example for discharging. Is that make sense, guys? Do you understand what we are going to do today?
So are we starting to use calculus?
You don't need the calculus. We have the equation solved for you. You only need to use the equation. So I'm going to give you the equations now. So we'll clean all this for the time being. Okay, so we can use this equation. Vt is equals to V naught e to the power minus t over tau. So this is the equation. This Vt is the voltage across the capacitor when time is equals to t, for any time. And V naught is the voltage across the capacitor when the time is equals to 0. And this tau, we call the tau as the time constant. And this tau is equals to RC. And you know R is the resistance, R is the RTH, the resistance, Thevenin resistance. We'll do a question, okay? Then you will understand this. RTH is the Thevenin resistance across the capacitor, and C is the capacitance. So this equation is the equation that we are going to use for normal, a simple RC circuit. Is that make sense, guys? Is it clear? Any question so far? We are going to do a question now and see. Any questions so far, guys?
What was the E, sorry?
E is the E,
just E.
Yeah, what we call that exponent, isn't what we call it?
Okay.
The E, E in the calculator, what do we call it, guys?
I think it's the exponent.
Yes, the inverse of the ln. So inverse of the ln.
Just the number E. I was thinking it might represent something else.
No, it's the E, yeah. It is an exponential the curves. So it's like this. Okay, we'll do one question from the book and let's see whether you have understood. Any questions so far, guys?
And tau was the RC.
Tau is RC, yes. Thevenin resistance, and the C is the capacitance. Okay, let's do this question. Any other questions? Okay, let's do the same question that we have discussed. This is the same question that we took to explain the theory. So now they are asking us to find the voltage across the capacitor. So what we need to do is we need to find the voltage across the capacitor. So we know we can find the voltage across the capacitor using this equation. Vt is equals to V naught e to the power minus t over tau. And tau is RC. So this is what we know. And let's see how to find these things. First, let's find this V naught. V naught, what is V naught, guys? V naught is what? What did I tell you? V naught is the voltage across the capacitor.
So it's 9/12 times 20.
Let's see. Now you have to look at your circuit. When you look at the circuit, what they say, in the circuit below, assume that the switch has been closed for a long time and it was open when the time is equals to 0. So V naught is the voltage when the time is equals to 0. So they are saying the switch was closed. Switch was like this for a long time and it was just open when the time is equals to 0. So when the time is less than 0, what is your circuit, guys? Your circuit will be like this, isn't it? This one is your circuit. Switch was closed. And when the time is less than 0, your capacitor will be charged. It was closed for a long time. So the capacitor is fully charged. The time is enough for capacitor to be fully charged. Am I right? So when the capacitor is fully charged, this will be open circuit. Am I right? So when the time is just 0, your circuit will be like this. Do you agree, guys? Am I right?
Yeah, the current stopped flowing through the open part of the circuit.
Yes. So if you can find the voltage across these 2 points, that will be your V naught. Do you agree? So what is the V naught? V naught is the voltage across the 9 ohms. So we already found it. Let's find it again. We use the voltage division rule, and 20 times 9 divided by 12, and this is 15 volts. Is that right? So V naught we found that is equals to 15 volts. Am I right? Now we need to find the tau. So what is tau? Tau is RC. This R is the RTH across the capacitor. So what do we mean by RTH, guys? How did we find the RTH from your week 5? How we define the Thevenin resistance? How did we find it? Can you remember? We switched off all the independent sources and we found the open circuit, the equivalent resistance across the open circuit, isn't it? Now, when you are finding R, you need to remember this. When you're finding the R, you need to consider the circuit when time goes to infinity. When the time goes to infinity, that means they are saying the switch was closed for a long time and it was open when the time is equals to 0. So when the time is equals to 0, the switch is opening. So when the switch is opening, you don't have this part in the circuit, right? This part is connected to the circuit only till time is equals to 0. Am I right or wrong? So when the time is more than 0, you have only this circuit. Am I right? You only have the right-hand side of the circuit because the left-hand side is disconnected. The switch is open. Am I right, guys? Is it clear or not?
Yeah, it's clear. I'm just having trouble understanding why it's important in terms of solving it.
Sorry, what's that?
It's okay. Yeah, it makes sense.
Okay. Now, when the time is more than 0, whenever you find the RTH, you need to consider the circuit when the T is more than 0. So you remember this. Put an asterisk and write it somewhere, because students I have seen when they solve questions, they sometimes use the wrong circuit to find RTH. This circuit. So when you consider this circuit, RTH is the open circuit voltage or open circuit equivalent resistance. So if you can find the equivalent resistance here, that will be your R. So RTH is equals to these two resistors, 1 ohm and 9 ohm, are in series. So this is 10 ohms. Do you agree? This RTH is 10. Am I right? Because 1 and 9 are in series. If that makes sense, guys, any question?
Is this after the capacitor is discharged? Sorry?
No. This is
So at t equals more than 0.
T is more than 0, you need to find the RTH. When you find the RTH, if you can remember in week 5, we discussed RTH is the open circuit voltage. So you make this one open.
So t more than 0 and t infinity are different circumstances.
Yes. When t goes to infinity, this is anyway open circuit, but t is more than 0. We can't say it is fully discharged. It can be still discharging. But it doesn't matter here, even if you consider t is more than 0 or goes to infinity, because anyway, we are considering open circuit, so it doesn't matter. You can consider any, that doesn't matter. Is it clear? So if you know the RTH, you can find tau. Tau is the time constant, tau is RC, R is 10, C is 20 milliamps, millihenries. So milli to millifarads, to make it to farads, it is like this. So that will be 1/5. Tau is a time constant and it is measured in seconds. Now you have everything. If you look at this one, you have tau, you have V naught. So you just substitute in this equation. When you substitute the things in the equation, you have Vt is equals to 15 times e to the power minus 5t. Am I right? So this is what they're asking you to find. So this is how the voltage changing across the capacitor. For any given t, if someone gives you the t, you can find the corresponding V for that t because you just substitute that t over here. Is it make sense, guys? Any question? These two are equal, right? So minus 5t is equals to t minus t over 0.2. It's the same thing, isn't it? These two are equal. Am I right, guys? So even if you have 5 or if you have this one, it doesn't matter. So these both the answers are right. Is that make sense? Any question?
I'm just trying to think. So when the capacitor is fully charged, you consider the right-hand side of the circuit open.
Yes.
And then this switch on the left, can I just ask, is that something, like, to conceptualize it, is that just something that somebody is operating?
Yeah, yes, you can assume like that. It doesn't have to be someone operating it. We can have another circuit to, like, to make the switch open and close. We can have sensors and do it like automatically, but you can assume like, yes, someone is opening the switch when the time is equals to 0. Yes. Is that make sense, guys?
Yeah, I was just getting stuck on something that probably didn't make sense. It's all good.
All right, let's do a few questions. And I think when you master this RC circuit, RL will be easier. So guys, things are getting hard. So you need to pay more attention now because electrical, I told you at the very beginning, you need to know the concept well to answer the questions. So it's not hard as long as you understand the concept. You will be learning more harder things in your second year, third year, fourth year. So it's a good practice now. You take attention because you are going to be like, you are the future of like engineering, isn't it? So we are doing harder things. So can I give you a few minutes for you to think and do this one? So don't look at the answer. Don't look at the answer. And this is the equation. Vt is equals to V naught e to the power minus t over tau. Tau is the RC. So use these two equations. And what you need to do is you need to find this one and this one. That's all you need to find. So to find V naught, what you need to do, guys, you need to first draw the circuit when the time is less than 0. So draw the circuit when the time is less than 0 to find V naught. And to find R, you need to draw the circuit when the time is more than 0. So first, you only need to find two things. To find the two things, read the question and first draw me the two circuits, guys. They are saying the switch in the circuit below is open at t is equals to 0. So when the t is less than 0, is the switch closed or open? What do you think?
Closed.
Close. So you have to draw the circuit, the right circuit. So when the t is less than 0, switch close. And when the t is more than 0, switch open. Okay, guys, did you get these two circuits? Am I have I done it right? Do you have the same thing or different? Do you get the same circuits? Alex, do you have the same circuit?
Yes.
How about others?
I wasn't quite finished yet, but I think I'm trying to work out if I was making sure I was going in the right direction.
Okay, yeah. How about others?
Yeah, kind of similar.
Okay. Now let's see what is happening. What do we mean by V naught, guys? V naught, I gave you the definition. V naught is the voltage when the time is equals to 0. When the time is equals to 0, what is happening? The capacitor will be fully charged. So this will act as an open circuit. Do you agree, guys? When the time goes to 0, when the time is 0, now you can look at this circuit. This will become open circuit. Do you agree?
Yes, and then more than 0, it begins discharging.
Yes. So V naught is the voltage here, isn't it? Voltage across this. So how you can find the voltage? Now you don't have any capacitors in the circuit. You have a circuit. Your circuit is this. How do you find the voltage across this point? This is the voltage you need to find. So what is the voltage over here? How do you find that? Voltage here is the voltage across 12 or 4, isn't it? Because 12 and 4 are parallel. If you can find the voltage across any of those, that is the voltage we know, isn't it?
Yeah.
Right, guys? So these two are in parallel. So you can make it to a single resistor, which is 12 times 4 divided by 16. I think it is 3 ohms. Am I right? And the rest of the circuit will remain the same. If you can find the voltage here, that is your V naught. Am I right? Have I done anything wrong? So your total voltage is 24. This 24 is divided between 6 and 3. How do you find the voltage across V naught? How do we find?
So 3 over 9 times 24.
That's right. So V naught is 24 times
8.
9. That's right. So that will be, what's that, 8? It's 8, right?
Yeah, it's a third of 24.
Yes. So 8 volts. So V naught, we found 8 volts. Anyone have any issues with finding V naught? Any question, guys? So this one is done. It is 8. Any question?
Miss, where'd you get the 9 from?
9, 3, 6 plus 3.
Oh, okay.
Voltage division rule. Okay, now let's see how to find the R. So to find the R, as I told you, we always use the circuit when the time is more than 0. When the time is more than 0, we already drew the circuit. So this is our circuit. This is what we are going to look at. And the resistance is the Thevenin resistance across the capacitor. So across the capacitor, the open circuit voltage. So this is 4 and this is 12. So this is the R, which is RTH. So 12 and 4 are in parallel. So what is your R, guys? R is 3 ohms. Am I right? We already found when they are parallel, 12 times 4 divided by 16. 16, isn't it? So this one also found 3 ohms. Now you just substitute, that's it. So when you substitute in the equation, what do we get? So Vt is equals to V naught is 8, e to the power minus t over tau is 3 times the capacitance, which is 1 over 6. So this is 1 over 2. Am I right, guys? So this is minus 2t. Am I right? Is it clear? Any question?
What Sorry, what was that -2 again? I think it just slipped my mind.
Tau is RC. So R is 3, C is 1/6. So this is a half, isn't it? So tau is a half. So when you put the half as the tau, you have minus t over tau. No, here you have minus t over tau, isn't it? Minus t over tau. Tau is half. Am I right? So this whole part will become minus 2t, isn't it?
That makes sense. Yeah.
Any question? Anyone have any question? Can you try the question number 4 by yourself? I'll give you some time. You do the same thing, nothing different. You do the same thing. First, draw the circuit when the time is less than 0 and time is more than 0. Then we can discuss. So I'll delete everything. So what is happening here? The switch, it doesn't say here. I'll write it here so that it will make. So the question is, the switch is was at A for a long time and turn to B when t is equals to 0. So do you understand what I mean, guys? The switch was at A for a long time. This is your A, and it was turned to B when the time is equals to 0. Does that make sense? Now you need to draw the circuit when the time is less than 0 and draw the circuit when the time is more than 0. And I'll give you a few minutes for you to try this. The two equations, don't look at the answer. Two equations are and tau is RC. So you only need to find two things. You need to find this one and this R. To find the R, use the circuit when the time is more than 0. And to find the V0, use the circuit when the time is less than 0. And I'll give you a few minutes. If you have any question, you can ask. How are we going, guys? So what is the circuit when the time is less than 0? Is this what you have? Am I right?
We ignore the 2 kilo ohms because it's not
Yes.
connected.
That's right, yes. So how about others? Do you understand what we are doing? Any question? And when the time is more than 0, what is happening? The switch is at B. Now what is your circuit?
So does that mean the voltage is now switched off, but the capacitor is charged?
Yes, switch was at A for a long time. So when the switch was at A for a long time, the capacitor will be fully charged. And yeah. Is that what you ask?
Yep.
So anyone have any question up to here? So this is a very easy one when you understand. If you don't understand, you feel like this is very complex, but it's not that complex. It is one of the easiest question that you get in the final exam. Now, if you see here, our aim is to find the V node. So what is V node, guys? V node is the voltage across the capacitor when the time is equal to 0. We discussed this at the very beginning. So when the time goes to 0, what is happening? Your capacitor will be what? Fully charged. When the capacitor is fully charged, what is happening, guys?
Circuit's open.
Yes, that circuit will be open. Now your circuit will be like this. And can't we find the voltage here? That is your V node. Circuit is open. So the voltage V node is what? So if this one is open, is there any current going here? Any current? Can a current flow in open path?
No.
No current. So no current means do you have any voltage across the 5?
No, it's 0.
0. So the voltage V naught is equals to the voltage across this parallel path. So V naught is 40 volts. Is that right? Is that right, guys?
Yeah, that's what I got.
We notice that. Then we need to find the RTH. To find the RTH, what we do, we consider the open circuit resistance here. So what is the RTH? 2 kilo ohms, am I right?
Yeah, because it's the only part of the circuit.
Yes. So that is, so what is tau now? We can find the tau now. So tau is equals to R times C. R is 2 times 10 to the power 3, isn't it? Because it is kilo ohms. And C is what? 10 times
10 to the negative 3.
minus 6 micro.
Oh, yeah.
So then this will become, what do we have? 2 over 100, am I right? So that means 1 over 50, isn't it? Is that right, guys? Am I right?
Yeah, I'm just writing down. I forgot to account the kilo ohms.
Okay, now we found this is our tau and this is our V naught. You just need to, so this is our V naught and this is the tau. So you just substitute in your equations, just substitute here. So when you substitute the things here, you can write Vt is equals to 40 times e to the power minus 50t. Am I right? Any question? Any question, guys? No questions?
So just to clarify, before zero, we work out the voltage. After zero, we work out the resistance.
Yes.
Then we use tau, and that should give us our information to get VT.
Yes, that's right. Yeah. So our answer and the answer given in the book are the same, because if you see this 50 is equals to that, isn't it? In maths, am I right, guys? So this and these two are the same, isn't it? You can write this one as 1/50, or else you can write this one as 0.02, isn't it? Both the same. Am I right, guys? So our answer is same as what we have in the book. So any question up to here? We are going to do a different now. Now this is the first, like the beginning part. Now we can go to more difficult parts. Are we all good with the basics? These are the basics. Now we are going to go a bit harder questions. Any question before we go to harder questions? No, okay. This we call the step response. When you do the lectures, you will understand. You have your test on Friday, in your second tutorial. Okay, now when you look at the question number 5, it is a bit different. Why we say it is different, guys? Now, can you tell me when the time is when the time is less than 0, what is happening? So when the time is less, your arrow is in this way. So that means when the time is less than 0, switch was closed. Am I right, guys? So your circuit will be this. Am I right? Is this right, guys?
And after zero, we don't have the capacitor in the middle. We just have the 10 volts, 3 ohms.
No. You have to now think. So your switch is open. When the switch is open, you don't have this part, but you still have the capacitor, right? Am I right?
Okay.
It will look like this now, isn't it?
But do we still we can't consider it open if it's fully charged?
When it is fully charged, yes.
It's discharging. Sorry, never mind me.
Okay, now this one is a bit different. Why is that, guys? Because now when you consider when the time is less than 0, your capacitor will be fully charged. Am I right? Now after, when you keep the switch closed for a long time, your capacitor will be fully charged. Do you agree? After some time, that will be fully charged, isn't it? So when the capacitor is fully charged, your circuit will be look like this. Am I right? And your capacitor was somewhere here. Now it is open because it was fully charged, isn't it? When the capacitor is fully charged, your circuit is this. Do you agree? Am I right? You need to talk. Otherwise, I don't.
Yeah, I think that's clear. It's the same as before.
Yes. Now, if you look at this one, after some time, the capacitor will be fully charged again. It is not discharging now. Do you see that? It's not fully discharging. It will be still charged under different conditions. Now, when the capacitor is fully charged, your circuit will look like this, isn't it? So this is where you have your capacitor. The difference here is when the time goes to infinity, your capacitor is still having a charge. So there is still a voltage. Voltage is not going to zero. You have a voltage. When the time goes to infinity, there is a voltage across the capacitor. When time is at zero, there is a voltage across the capacitor. Do you understand that?
So anything beyond 0, there's a voltage across the capacitor. Sorry, is that?
When the time is equals to 0, there is a voltage across the capacitor. When the time
right.
infinity, there is a voltage across the capacitor. In between these two, voltage is changing from V0 to V infinity. So when you have this kind of situation, we can't use the previous equation. You have a different equation. So please note down this one as well. You have this in the lecture note. So this equation is true for previous case and also for this one. It doesn't matter. You can use this as a single equation where you can use for any kind of problem, even for the previous ones. So this is our new equation. This is true for any kind of circuit. So in this equation, let's see what do we mean by these numbers. So V infinity is the voltage across the capacitor when time goes to infinity. And V naught is what, guys? V naught is the same thing. What do we mean by V naught? We discussed before. Voltage across the capacitor when the t goes to 0, when the time is equals to 0. And tau remains the same. Tau is the RC. R is the resistance when the time is more than 0. So do you see the difference, guys? Is that make sense? Any question?
Was tau time? Sorry?
Tau is RC, the same as the previous one.
Yeah, and that's our time in the equation above.
R is the same when Thevenin resistance when the time is more. You consider the circuit when the time is more than 0 and you find Thevenin resistance across the capacitor.
Is that what we use to get the time that we consider in the voltage equation?
It's the same.
No. So we have e to the power of negative t over 2.
T over tau. Tau.
Oh, right.
The time constant, the same tau
Sorry,
that we used before. Yeah.
That's all good. I was just misreading.
Okay, now let's see. Here, the only difference is we have to find 3 things. Before we had to find 2 things only. Now we have to find 3 things. So what are the 3 things? V infinity, V naught, and the tau or the R. So V infinity, you look at this circuit and you find the V infinity. What is the V infinity in this case, guys? Look at this circuit and what is the V infinity? Is there any current going across this resistor? No, because it is open. So what is V infinity? That is 10 volts. Do you agree?
Yep, that's clear.
So if you look at this circuit, when the time goes to 0, what is your V naught? What is your V naught here? V naught is, you use the voltage division. V naught is the voltage across the 2, isn't it? Am I right? So that is 10 times 2 divided by 5, which is equals to 4. So V naught is 4, V infinity is 10. What is the resistance? Where do you look at to find the resistance?
The time after 0, so the circuit
Yes.
after the time is 0.
You look at this one and you switch off all the independent sources. So your circuit will look like this, isn't it? So your RTH or the R is equals to 3 ohms. Do you agree? Do you agree, guys?
Just taking notes. Yep.
Okay. Yeah. Okay, now let's put the numbers. Let's put the numbers and see what we get. So R is, sorry, it's not 3, it's 2, isn't it? Sorry, guys, this is 2, isn't it? This one is 2. This is 2. It's 2 here. So this is 2. When I written it, I wrote it as 3. That's my bad. So resistance is 2. V naught is 4. V infinity is 10. Just substitute in the equation and see what you get. Just substitute in the equation. So in our equation, we have Vt is equals to V infinity plus V naught minus V infinity e to the power t over tau. We just substituting the values. So V infinity is 10 plus V naught is, sorry, I think 4 minus 10 e to the power minus t over tau. Tau is times 7, isn't it? 14. So t over 7 or 14, sorry. So you can write this one as 10 minus 6 e to the power minus t over 40. Do you get the same?
Yep, I got the same.
How about others? Any question? Okay, can I give you one question for you to do? I think that's
Is the voltage infinity always going to be the maximum voltage of the circuit?
it depends on your circuit.
Okay.
Yeah. So because it will, when we do few questions, you will understand it. So can this is inductor. We didn't do inductors yet. Okay, let's do this. Okay, do the question number 13. Okay, do the 14. I'll give you a few minutes. Just do part A, then we'll discuss part B, maybe do part A. If the switch in the circuit has been open for a long time and is closed when the time is equals to 0, and you need to find, have you written down the equations, guys? I'll write it here anyway. Yeah. So these are the two equations. So you only need to find 3 things. This is one, this one, and the R. So these are the 3 things that you need to find. So to find these 2, you need to draw the circuit when the time is more than 0. And to find the V naught, you need to draw the circuit when the time is less than 0. First, draw the 2 circuits and then start doing like solving it. If you need help, you can ask. I'll give you some time. How are we going, guys? Have you drilled the circuits? So they are saying switch was open for a long time. So switch was open for a long time. When the time is less than 0, your circuit is look like this. Is that right? Am I right?
I can find B, but I'm having trouble working out A.
Switch was open for a long time and it closed. So this is the circuit when the time is less than 0, and the circuit when the time is more than 0, it is like this. Isn't it?
Yeah, that's what I've drawn.
Okay, now we need to find V naught. We can find the V naught here. So V naught here is, it was open for a long time. So when the time goes to 0, when the time is 0, this circuit will be fully like, the voltage across this one V naught is 0. Do you agree?
Yeah, because there's no voltage.
Yes,
connected.
and that's right. So when the time goes to infinity, what will happen is this will become open and the voltage V infinity will be the voltage across the 4 ohms, isn't it? Am I right? If you find the voltage across the 4, that will be your voltage V infinity, isn't it? Is that right?
Right.
So V infinity is 12 times 4 divided by 6, which is 8 volts. And what is RTH? So RTH is you switch off the voltage source, so your circuit will be look like this. Am I right?
So it's just 6.
So 2 and 4 are in parallel. Am I right? So R is equals to 2 times 4 divided by 6. What's that?
1.33 or 8/6.
Okay, so 4/3, maybe we'll write like this. Yes, so we found that, and let's substitute in the equation. So Vt is equals to V infinity, we found 8 times V naught is 0 minus 8 times e to the power minus 3t/4. Is that right? Am I right? So this will be minus 64 e to the power minus 3t/4. Some answers are wrong, guys. If we have done it right, it is right. So is that what you get? Is that what you get?
I was just rewriting it. I was trying more to get the answer that was given than to just do it.
No, sometimes the answers are wrong. If you see the working out, we can so let me see the workings here. You have the solutions here somewhere in views, right? Solutions. I think it's in the modules. Module 7. tutorial solutions response. Which one we are doing? Question number 14. They haven't done the question number 14. Yes, question number 14 is not there. So don't worry about the answer, because as long as we follow the right steps, it will be like, you know, it's right. Some answers are wrong. So this is the answer. Is there any question, guys?
But Miss, isn't it supposed to be plus instead of a like minus 64? It should be 8 minus 8e elevated, you know, I think.
Where is that?
At the final answer,
Yes.
the 8 times 0 minus 8 times e, shouldn't it be 8 plus and then brackets 8 minus 0? 0 minus 8. You know, instead of times, it's supposed to be a plus.
Yes, that's right. Yeah, my maths. Yeah, yes, you are right. What's that? No, 0. So this is 0. So 0 times 8 is 0. So this 8 times 8, this is 64, isn't it?
No, what I mean is that it's supposed to be a plus instead of a times, like in the formula, right? Like
In the
8
equation.
plus-
Yes, that's right. Sorry. Yes, that's right.
Okay,
The answer is, I think, almost the same, isn't it? So we have a plus here. Sorry. Yes, that's right. So we have 8 plus 8 minus 8 times e to the power minus 3t over 4. That's right. So we can take the 8 out because 8 is common. So we take the 8 out. Then we have 1 minus e to the power minus 3t over 4. That's right. Yes. Yes, guys. So yeah, we have the answer. Yes. 0.2, 3 over 4. So 3 over 4 is that 0.2 something. 0.75. Yeah, that's okay.
I think you use the resistance instead of times it by the F3F. I think.
Yes, that's right. Yeah, that's, sorry, yes. So I have done wrong thing, guys here. So thank you. Yes, this is the resistance. Now what is tau? Tau is RC. So we need to times that by 4 over 3 times 3. So this is 4. Yes, that's right. So this will be T over 4. So T over 4 is, you can write that one as 0.25, isn't it? Yeah. Yeah, thank you. Yeah, so the same answer, what we have the same answer. Is that clear, guys?
Yeah, that's good now.
Yeah, see, now you guys are better than me, so that's I'm happy. So it's good. Okay, can you try the part B? Can you try this one now? Which was closed for a long time and it's open when the time is equals to 0.
So we just have 4 times 3 as our RC, which would give us.
Now what is happening is your circuit will be switched, isn't it? So your resistance will be different. And also if you, now this is the circuit when the time is infinity. So else time is more than 0. So this is the circuit when the time is more than 0. And this is the circuit when the time is less than 0. So you swap those two circuits, isn't it? Am I right?
Yep. So now we just have the 4 ohms and the 3 Faraday.
Now, if you look at this one, this is your V naught and your V naught is 8. Am I right? And your V infinity is 0. Am I right? And what is RTH, guys? Which circuit you are looking at now to find the resistance? You always need to look at the circuit when the time is more than 0. So if you look at this one, when this is open, what is your RTH?
It's just 4.
It is just 4. So your tau is 4 times 3, which is 12. 12 seconds. Now you substitute in the equation. When you substitute in the equation, so I use the same thing here. So we have Vt is equals to V infinity, which is 0, plus brackets, V naught is 8, minus 0, e to the power minus t over 12. So this will be 8t to the power minus t over 12. Okay. So any question, guys? So that's, you can do any of RC circuits now. Any question? So there are more questions, you can do it. I'm going to start the RL. Is that okay, guys? Can you do the other questions that you have? Can you try as homework? Okay, let's see RL circuits. RL means, RC means we have resistors and a capacitor. RC circuit is you have inductor and resistor. So here, let's start with a simple circuit. So in this circuit we consider it as a RL circuit. Why is that? We have resistors, we have many resistors and one inductor. So this kind of circuits we call RL circuit. Again, this is a first order circuit because we can explain this with a first order differential equation. Here again, we have two situations, but you have like, if you consider this one, in this kind of circuits, in RL circuits, what is happening is the current across the inductor is changing with the time. When it is charging and discharging, the current across the inductor is changing. So that current across the inductor is given by this equation. So I naught times e to the power minus t over tau. So again, similar to the capacitors, RC circuits, this is the current across the inductor when the time is equals to 0. And tau in this case is a bit different. Tau is equals to L over R. And L is the inductance and R is the RTH across the inductor. Inductor when the time is more than 0. So is it clear, guys? So when we have RL circuits, we can use this equation. And here I notice the current across the inductor when the time is equals to 0. And tau is L over R. Okay, now let's see. We'll use this circuit and we are going to solve this one using this equation. Again, like in the RC circuit, first we need to draw the two circuits. When the t is less than 0, draw the circuit. When the t is more than 0, you need to draw the circuit. When the t is less than 0, they are saying, when at t is less than 0, draw the, what they say. So switch was, when the t is less than 0, the switch was closed, isn't it? And when the t is more than 0, switch was taken into the arrow side. So this is open switch. Can you draw the two circuits, guys? So when the t is less than 0, switch was closed. So our circuit will be look like this. Am I right? Is that right, guys? Do you have the same, guys?
Yep. And then after 0, you'd have the 4 ohms and the 24 volts disconnected.
That's right, like this. So these are the two circuits. Now, when the time is 0, when the time goes to 0, if you can remember last week, when an inductor is fully charged, this will be fully charged. When it is fully charged, this branch will become short circuit. Can you remember from the last week? So this branch will be short circuited. And if you find the current, that current is your I node. Am I right, guys?
So the I naught is the current across the short-circuited inductor.
Yes. So how do we find that I node? It's
current division.
Yes, this is a voltage. So 24 volt is a voltage. So that 24, if you can find the, if you can find the voltage across these points, or else if you can, so if you can find the voltage across these 2 points, you can find the current, isn't it? So what's the voltage here? That voltage you can find. These two resistors, 8 and 4 are in parallel. So if you add them, you can convert, you can make it to a single resistor. 8 times 4 divided by 12, which is 8/3, isn't it? Am I right? So you can find the voltage. Voltage is 24. 8/3 is what? It's up to you how you want to solve it, because you know different methods now. So this is 2.67 ohms. So this voltage will be 24 times 2.67 divided by 6.67, isn't it? Am I right, guys? Am I doing it right? $9.6. That voltage is 9.6. If you want to find I node will be 9.6 volts divided by 8, isn't it? So that is 1.2 amps. Am I right, guys? Does that make sense? Is it clear or not?
Yeah, that's good.
Okay, now we found the I node. We need to find the resistance. When we need to find the resistance, we look at the circuit where the time is more than 0. So we look at this circuit. You look at the circuit and you find the resistance across the inductor. This is the inductor. So if you find the open circuit resistance across the inductor, So if you look at this 4 and 8 are in series. So your RTH is what, guys? RTH is 12 ohms, isn't it? If RTH is 12 ohms, your tau is L over R. L is given to us 4 over 12, which is 1 over 3, isn't it? So this is the tau. This is the I naught. Just substitute in the equation. When you substitute in the equation, IT is equals to I naught is 1.2 e to the power minus 3t. Am I right? If it makes sense.
Yeah, I'm just finishing writing that down.
Yeah. If you're done with that, you can now try the question number 7.
Miss, about the test,
Yeah.
which topics is it gonna cover?
Topic 1 to 5, including 1 and 5.
Thank you.
Okay, can I move to the question 7 and
Yep, I think that's all good.
okay, so question number 7. Yeah, it's a capacitor. Don't do this one because you know that. Maybe question number 8. I'll give you a few minutes and then we'll do together. Maybe yeah. Just try by yourself first. If you understood the RC, this one you can do. I'll write the equations again here. So IT is equals to I naught e to the power minus t over tau. Here the tau is L over R. So you need to draw the circuit when the t is less than 0. You need to draw the circuit when the t is more than 0. So if you read the question, they are saying when it was open for a long, switch was closed for a long time. So switch close, and when the time is more than 0, switch open. Yeah, draw the two circuits and find you only need to find 2 things, guys. So find the 2 things. Okay, guys, so did you get the same circuits? To find I naught is the current when the time goes to 0. So when the time is 0, the inductor will be fully charged and this will be short circuit. If you find this current here, that will be your I naught. So what is I naught, guys? Now you need to think, you have a short circuit path with a parallel 4 resistors. So when the current comes to here, so current is produces by this one. So when the current comes to this node, where it is going? Is it going across the 4?
Yes, and it's parallel to the 2.
This is a short circuit path. This 2 is Henry's. You don't have it now because it is short.
Oh, okay, I see.
So where the current goes?
Just across the 4.
It doesn't go across the 4. It's going in the short circuit path. Isn't it? Because there is an easy way to current to flow. It doesn't go through the resistor. So that 4 is not functioning. So what's the current I naught? Does that make sense? I naught is 12/3, isn't it?
Yep, so it's just 4, right? Okay, I had that at first and then I started confusing myself.
Okay. That we found. And then to find the resistance, we are looking at this circuit. So resistance is the open circuit resistance here, RTH. So that will be what? That is 4 ohms. So you substitute in the equation, IT is equals to I naught is 4 e to the power minus tau, we find the tau is L over R. L is 2, R is 4, so this is half. So minus 2t, isn't it? Am I right? Is that what we have? Yes. Is it clear, guys? Any question? No questions?
I think that's okay.
Okay, now we need to see, so there can be situations. Here you can see, if you look at the circuit when the time goes to infinity, if you consider the circuit when the time goes to infinity, your inductor will be fully discharged and the current goes to 0. But there are situations where the current is not going to 0, like in the capacitors. We call this kind of circuits the first response. We have this, we call the natural response, or else this is just discharging, fully discharging. But there are situations where the inductor is not fully discharged. Let's do a question like that, like we did in the capacitor. So if you consider this one. Yeah, if you consider this circuit, guys, it's a bit different to the previous one. If you consider t is less than 0, if you draw the circuit, they are saying the switch was has been closed it was closed for a long time. So that means switch was closed for a long time. It is like this. So when the time is less than 0, you have a circuit like this. Am I right? When the time is more than 0, you have a circuit like the switch is open now. So these are the two circuits, isn't it? Why didn't I wrote the 3 here? Because when you have a short circuit path, this 3 is not functioning. So that's why I didn't draw the 3 here. Am I right? So these are the two circuits. If you look at the two circuits, so in this case, your inductor will be fully charged because of this 10 volts. And also if you look at this circuit again, this will be fully charged under different condition. You have two resistors here. So in both the cases, your inductor will be charged. It is not fully discharging and going, current is not zero, isn't it, guys? Is that make sense? So when you have this kind of circuits, you have a different equation to use. That equation is similar to the one that you use for in capacitors. So this current is equals to I infinity plus I naught minus I infinity e to the power minus t over tau. The same equation, now it's with currents. It is same equation that you use for the inductors. And here again, tau is L over R. So here the difference is you have I infinity. I infinity is the current across the inductor when the time goes to infinity. So you look at this one and you find the I infinity. And the others are the same. So this is the current when the time goes to zero, and this is the resistor when the time is more than zero. So let's do this. So you can find this I naught from this. So I naught is the current when the time goes to zero. When the time goes to zero, this path will be short circuit, and this current is your I naught. Do you agree, guys? So that current will be 10 over 2, which is 5 amps. Am I right?
Yep, that's pretty clear.
And when you consider the I infinity is the current when the time goes to infinity. When the time goes to infinity, this inductor will be fully charged again, and this current we call that I infinity. So this current will be 10 divided by these 2 and 3 are in series. So this is 2 amps. Do you agree?
Just checking. So at I infinity, we consider this switch closed. So
Switch is open. Switch is open. Switch is open. See, switch is open. So there is no path here.
Oh, but the circuit isn't shorted, so we still consider the 3. Oh.
Yes, because it's open. It's not there now. There is no short circuit path. And also to find RTH, you look at this circuit and you turn off the independent sources. So you have 2 and a 3, and this is your R. So R is equals to 5 ohms. Is that right?
Right.
And your tau is L over R. So that means 1 over 50, isn't it? Now you have everything. You just need to substitute in the equation. So this is tau. This is I infinity. This is I naught. So you just substitute everything in the equation. So you have IT is equals to I infinity is 2 plus I naught is 5 minus 2 e to the power minus 15t. So this will be 2 plus 3 e to the power minus 15t. Am I right?
Yeah, that's
okay. So any question? So
I think I just need to practice it a bit. The equations are fine.
Yeah, there are a lot of questions here. We didn't do all the questions because I had to explain the theory, but you attend the lecture as well, so that you when you hear it again, it will be easier for you to remember things. So attend the lecture, and Marina will explain more about this with other theories. So you have only 4 equations for this section. As I told you, you don't have to use the previous equation. You can do everything with this one. If you use this equation, even for the simple questions, you still, your I infinity will be 0. That's the only difference. So you have the same equation. Okay, guys, so you can solve any question with this equation, in any inductor question with this equation. You don't have to have that simple one. Okay, so do you like to do one more question, or are you tired?
I'm getting a bit tired. I'm finding it hard to follow, but I think it's just because I'm a bit drained.
Yeah, this section is like you need to practice more, then you will be, yeah, good. So do the other questions at home and let me know if you have any issues. We can discuss next week. Sorry, this Friday you have the test. So anyway, test is 1 hour and you have 15 minutes for uploading. So I don't think we can do much on that day. We have to do the test as we have to do the test. Get prepared and come. Your test will be on the first 5 topics. And we will start at the beginning of the class. Okay, guys, if you have any question, we can discuss quickly before the test. But otherwise, if you don't have questions, we are going to start the test straight away because it's just 1 hour test.
Are we able to email you if we have problems with anything throughout the week?
Yes, but don't email me to the student email address. I'm not, so just email to the one that I am sending. So
The tutor one that's listed on the views.
That's right. Yeah, just use that. Yeah. Okay. So any question, guys? Please type your student numbers in the chat for my attendance. Any question? No questions? Okay, then I'll see you on Friday, guys.
See you Friday. Thanks, Miss.
Okay, bye.